Okay, let's try another example of case number 2 where we are dealing with the non-homogeneous Euler equation. Okay, where we can see that in the right side here is not equal to 0, therefore this one is non-homogeneous, and because of the coefficient of your derivative and y is not equal to constant, here you have a constant with the variable, therefore this one is Euler equation. Okay, so when we are dealing with non-homogeneous, we know that we will have two solutions, which is the complementary solution and also YP particular solution, and at the end of the calculation we will combine both by superposition principle, where the general solution of our differential equation will be the complementary solution at plus with the particular solution. So because of this one is Euler equation, then we need to use the Euler method to solve our YC, to find our YC, where to solve or to find the YC, we will first let our y equal to x to the power of m, and you need to check that here in the equation you will have y, y prime and y double prime, means that you need to find the value of y, y prime and y double prime. So you already have y here, so we differentiate y to find y prime, we will get m x to the power of m minus 1, and again we differentiate y prime to get y double prime, it will be m minus 1 x to the power of m minus 2. So what we will do is we will substitute all these into the derivative and also y. So we will have the new equation as x squared y double prime is m squared minus m x to the power of m minus 2 plus with x multiplied by y prime, so your y prime is mx m minus 1 minus with y, your y is x to the power of m, and we will let it equal to 0 because we want to find the complementary solution yc. Okay, and expand this equation, what you will have is m squared minus m x to the power of m, because this one is 2 minus 2 is 0. Okay, and then you have plus with m x to the power of m, because this one is 1 minus 1 is equal to 0, and you have minus x to the power of m is equal to 0. Okay, and you can factor out the x to the power of m because all your variable or all your term here have x to the power of m. So we take it out, x to the power of m, in the bracket we only have m squared minus m plus m minus 1 equal to 0. This one we bring to the right, it will be equal to 0. So what we have in our quadratic equation is only m squared minus 1, because this one is negative m plus m equal to 0 equal to 0. So you have your m squared equal to 1, so your m is equal to plus minus square root 1. So your m1 equal to 1, your m2 is equal to negative 1, or you can directly calculate by using your calculator, because here you already have your quadratic equation. Okay, just substitute the value of a, b and c to get the root. So if you see here, you have the real and distance root, because your first value of m is positive 1 and the second one is the negative 1. Therefore, we will have our complementary solution as c1x to the power of 1 plus c2x to the power of negative 1. So here is your yc. Now, we want to find our yp, and we want to use the variation of parameter method. So, the first step in the variation of parameter method is to declare what is your y1 and what is your y2, where your y1 and y2 can be found or can be take from the complementary solution. This one is your y1 and this one is your y2. Therefore, you have your y1 equal to x and your y2 equal to x negative 1. So you can find your y1 prime, which is 1, and your y2 prime will be negative x to the power of negative 2. Okay, and then step number 2 is to create the equation, where the first equation will be y1 u prime plus y2 v prime equal to 0. So you will have x u prime, because your y1 is x, plus with x negative 1 v prime, because your y2 is negative 1 is equal to 0. This one is your first equation. And your second equation come from y1 prime u prime plus y2 prime v prime equal to fx divided by a. So your y1 is equal to 1, so you have u prime plus y2 prime is equal to negative x negative 2v prime equal to fx over a. So your fx is on the right side here, which is ln x, and the a is the one in front of the second derivative, which is x squared. So you have ln x over x squared. Alright, so this one is your second equation. So step number 3, we need to transform from the first equation and the second equation into the matrix form, where you have the variable u prime and v prime. So the first coefficient is x, the second one is x negative 1, the third one is 1, and the fourth one is negative x negative 2. So we just need to write it up, x 1, x negative 1, negative x negative 2, and you have your answer is equal to 0 and ln x divided by x squared. Okay, so step number 4, you need to find the Wronskian value w, where Wronskian value can be found by finding the determinant of this matrix. So you have here x 1, x negative 1, negative x negative 2. So to find the determinant, you just need to use the formula where the first one is to multiply this element minus with this element. So what you will have here is x multiplied by negative x negative 2 minus with 1 multiplied by x negative 1. So what you will have here is negative x 1 minus negative 2 is negative 1 minus with x negative 1. You need to remember that if you have x to the power of 1 multiplied by x to the power of negative 2, when the variable is multiplied, what you need to do to the power is plus. Okay, so it will be x 1 plus negative 2. Okay, so what you will have is x 1 minus 2. That's why you have x negative 1 here. Okay, so you just need to remember the law of exponent. This one using the law of exponent if you forget it. Okay, so from here you get your value is negative 2x to the power of negative 1. This one is your Wronskian value. Okay, next we need to find in step number 5 what is our u prime. To find u prime, we need to find the determinant of matrix U. How to find determinant of matrix U? The first column need to be substitute with this one. Okay, so we just write 0 ln x over x squared, and the second column we just copy x negative 1, negative x negative 2, and we need to divide it by the Wronskian value. Therefore, the determinant of this one is 0 multiplied by negative x negative 2 minus with x negative 1 multiplied by ln x over x squared, divide by your Wronskian, which is negative 2x negative 1. So here is 0. So you have here negative ln x over x to the power of 3 divided by negative 2 over x. Okay, so negative and negative positive. This one x cube dengan x boleh potong. So what you have is ln x, 2 ln x over x to the power of 2. So this one is your am I right? 2 dekat bawah. Ataupun kalau you confused, it will be like this, ln x over x cube darab dengan x over 2. So this one and this one can be cancelled out. So what you have here is ln x over 2x squared. Okay, so this one is your u prime. Okay, this one is your u prime. And then we want to find what is our v prime. To find v prime, we need to use, or we need to find the determinant of matrix V. So what is the determinant of matrix V? You need to substitute this column with this one. Okay, so just substitute it. Let it become 0 ln x over x square, and the first column we just need to copy x and 1, okay, and divide by the Wronskian value. Okay, therefore the determinant of this one is x multiplied by ln x over x square minus with 0 multiplied by 1 divided by negative 2 over x. I bring this one down. Okay, so here and here can be cancelled out. So you have here ln x over x multiplied by x over negative 2. This one can be cancelled out. Okay, so you left only ln x over 2, negative value. So this one is your v prime. Okay, that one is step number 5. Step number 6 is to find u by integrating your u prime with respect to x. So now you have your u prime is equal to this one, ln x over 2x square. Okay, ln x over 2x square dx. So you cannot directly integrate this one because it's involved two functions. You need to use the integration by part. The first one, you let your u equal to ln x, and you let your dv equal to okay, this one I bawa keluar 1 over 2 kat depan. So you only left with ln x over x square dx. So u equal to ln x, dv equal to x kuasa negative 2 dx. Okay, so yang ini kita differentiate dapat du dx, which is differentiate ln x, awak dapat 1 over x. So du equal to 1 over x dx. Okay, this one kita integrate dv untuk dapat v. So integrate x negative 2, you will get x negative 1 over negative 1. So you have your v equal to x negative 1. Okay, and then masukkan dalam formula by part, which is u v minus integrate v du. So your u is equal to ln x, your v is equal to negative x negative 1 minus integration of v darab dengan du. So you will have integration of negative 1 over x square dx. Okay, so negative and negative is positive. Here you have negative ln x over x. Saya bawa yang ni turun bawah. Okay, so tambah dengan integrate 1 over x square dx, ataupun kita tulis dia integrate x kuasa negative 2 dx. So apa yang awak akan dapat adalah cakap salah, v du. Okay, apa yang awak akan dapat adalah negative ln x over x tambah dengan x kuasa negative 1 bahagi negative 1 plus c. So we have negative ln x over x tolak x tolak 1 over x. X kuasa negative 1 sama dengan 1 over x plus dengan c. So this one is your u. Baru dapat u. Sekarang kita nak cari v. Okay, kita nak cari v. Okay, sekejap. Macam mana? Sekejap ya. Saya bawa turun ke bawah dulu. Okay, so sekarang kita nak cari v. Nak cari v samalah juga. Nak cari v, kita kena integrate v prime kepada x. So maksudnya kita kena integrate v prime kita tadi adalah negative ln x over 2. So negative 1 over 2 ln x dx. Sama juga yang ini kita kena guna integration by part, sebabnya tak boleh nak integrate ln. Okay, so kita akan pilih kita punya u adalah ln x. kita punya dv adalah negative 1 over 2 dx. So kita akan differentiate u dapat du dx, differentiate ln x dapat 1 over x. So du sama dengan 1 over x dx. Okay, integrate dv, awak akan dapat integrate negative 1 over 2. So awak akan dapat v, which is negative 1 over 2x. Okay, integrate constant, just tambah x lah. Okay, so kita masukkan dalam formula uv minus integration of v du. So your u darab dengan v, you will get negative 1 over 2x ln x. Okay, minus with integration of v darab dengan du. Okay, so x dengan x potong, negative 1 over 2 dx. So what you have here is negative 1 over 2 x ln x plus integration of 1 over 2 dx. Okay, so you will get negative 1 over 2x ln x plus 1 over 2x plus with d, sebab kita dah guna c. Okay, so kita ada d. Okay, so now class, you already have, this one is your v, and you already have your u. So we can find our yp, because yp is equal to u multiply by y1 tambah dengan v multiply by y2. So your u is all of this. Okay, so your yp will be u. So this one is your u, negative ln x over x minus 1 over x plus c multiply by y1. So your y1 is x, your y2 is x negative 1. So multiply by x plus v. This one is your v, negative x ln x over 2 plus 1 over 2x plus d multiply by y2. Your y2 is x negative 1, ataupun kita boleh tulis dia sebagai 1 over x. Okay, so you can see here, when you multiply negative ln x dengan x, you boleh potong x yang bawah ni. So dia tinggal, your yp tinggal negative ln x. Sama juga macam ni, you boleh potong, so tinggal negative 1 plus with c darab x is cx. Okay, so yang ini pula, bila ini darab dengan ini, yang atas dengan yang bawah boleh potong. So kita tinggal negative ln x over 2. Okay, sama juga yang ini, bila darab, yang ini dengan yang bawah boleh potong. So you have plus 1 over 2. Okay, and then yang ini darab dengan ni, you have plus d over x. Okay, so this one is your yp. So now we need to combine our yc and yp to get our y. Okay, di mana yc kita adalah c1x plus c2x1. So let's combine. Y equal to c1x plus c2x to the power of negative 1. Okay, lepas tu kita combinekan dengan yp kita. This one is all your yp. Just paste it here. Okay, so sekarang kita tengok yang mana yang sama. Okay, so yang ini kita tulislah x kuasa negative 1 supaya nampak. Okay, so kalau you tengok dekat sini, sekejap oh, sekejap. Oh, yang tadi saya terlupa. Saya bawa keluar 1 over 2 kan. So, jawapan last kali dia kena darab dengan 1 over 2. So, kat sini ada 2. Kat sini pun ada 2. Kat sini ada constant lah. So, u kita adalah negative ln x over 2x. Okay, kat sini ada 2. So, kat sini ada 2. Kat sini ada 2. Kat sini ada 2. Okay, sebab tadi saya keluarkan 1 over 2 tu saya lupa nak darab. Okay, so kat sini adalah negative ln x over 2 minus 1 over 2. Okay, so class, if you can see here, c1x dengan Cx, kita boleh combine, dia akan jadi Y sama dengan C1 plus Cx duduk dekat luar, yang pertama. And then we have C2x kuasa negatif 1 dengan dx kuasa negatif 1 boleh combine, dia akan jadi tambah C2 tambah dx kuasa negatif 1 dekat luar. And then you have here, if you see, negative half tambah dengan half kosong, habis. Okay, negative half tambah half kosong, habis. And then another one you have here, negative ln x over 2 minus ln x over 2. Okay, negative ln x over 2 minus ln x over 2, you will get negative ln x. Okay, so you have negative ln x. Okay, and this one is constant plus constant, it will be another constant. Let's say we put ax plus constant is another constant. Let's say we put b, x negative 1 minus with ln x. So this one is the solution to your non-homogeneous Cauchy-Euler differential equation.